My name is Jimmy Yang. Today I will continue to talk about complex multiplication, elliptic curve with complex multiplication over real number field. This is the paper authored by Professor P. Clark, and I will talk about corollary 3.8. Corollary 3.8. Let I be a primitive proper real or ideal. So there are many conditions here. It must be primitive, and it must be proper, and it must be real, and it must be all ideal. So under these four conditions, that let I be a primitive, proper, real, or ideal, then the index of I inside O divided the discriminant. So this is the we continue to understand. We continue to try to understand the relationship between O and lambda. O and lambda. O is a ring of endomorphism. That is an endomorphism ring, and lambda can be viewed as a lattice or an ideal. And above all of the ideal that we are consider, some kind of ideal are I, which are proper ideal. And of course, we want to consider the real ideal. That is the kind of ideal such that the elliptic curve will be defined over real number field. Okay, so and we consider a subset of lambda such that it is proper. If lambda is proper, or we call it I, then this is kind of the ideal that it has a special relationship such that the isogeny will preserve the endomorphism ring. Okay, so if we consider a primitive, proper, real, or ideal, that is, it is also primitive. Primitive means that it looks like a prime ideal, that is a prime cyclic group. So primitive can be viewed as a concept like a prime order cyclic group. That is the kernel of the ideal. Kernel of the isogeny is a prime order cyclic group, and the ideal can be viewed. Ideal can correspond to an isogeny, and the primitive ideal correspond to a cyclic isogeny. And the kernel of a cyclic isogeny, if it is with a prime ordered kernel, then the ideal is look like a primitive ideal. And in this case, the I inside O, the index of I inside O, divide discriminant. The index of I inside O is divided discriminant. So the proof is very short that for all ideal I of the form 1 and 2 above, we have that the index of I is equal to A and A divided discriminant. Okay. And because this is too short a proof for a proof, we can consider another paper of P. Clark. There is a longer proof here. In another paper of P. Clark, that is a paper of CM elliptic curves, volcanoes reality applications, part 1. And we consider the theorem 2.9. 2.9 here. A non-zero O ideal I, it must also be an O ideal. A non-zero O ideal I is primitive if the additive group of all quotient by I is cyclic. This holds if only if there is no n bigger or equal to 2, such that n inverse I remains an integral O ideal. Okay, let's talk about theorem 2.9. Let O be an imaginary quadratic order of discriminant delta, which is equal to f squared delta k. If there is a primitive, proper, real, or ideal, so the condition is the same. It must be primitive, proper, and real. And it must be an O ideal of the index n. Of index n, then n divided discriminant of delta. So this is the same equivalent condition here. If there is a primitive, proper, real, or ideal of index n, then n divided discriminant. Okay. And then we consider the case that here, let L is bigger than 2. L is bigger than 2. And let A be a positive integer. There is a primitive, proper, real, or ideal I such that the index of I inside the O is L to the S power. If only if A is the order of discriminant under the basis of L. That is the biggest A such that L to the S power divided discriminant. The notation is the order ORD of discriminant under the basis of L, which is A, and A is the biggest number such that A is the biggest number such that L to the S power divide discriminant. And let L is bigger than 2, then there is a primitive, proper, real, or ideal such that the index of I inside O is L to the S power if only if A is the order of discriminant under the base of the L. I will read it again. Let L is bigger than 2. Let A be a positive integer. There is a primitive, proper, real, or ideal I such that the index of I inside O is L to the S power if only if A is equal to the order of discriminant under the basis of L. Okay. Thank you very much.